Welcome students for classification of elements and periodicity in properties, KCET, NEET, JEE, lecture 2nd. Let's continue with the first question. The less negative electron gain enthalpy or energy of fluorine than that of chlorine is due to, and the options are option A, smaller size, option B, smaller nuclear charge, option C, difference in their electronic configurations, and option D, its highest reactivity. Students, because of the small size of fluorine, electron-electron repulsion present in the relatively compact 2p sub shell that do not easily allow the addition of an extra electron. And on the other hand, if we see the chlorine atom, because of its comparatively bigger size than fluorine, it allows the addition of an extra electron much easier. And thus, we can conclude that the electron affinity of chlorine with negative sign is much greater compared to that of fluorine. So with this, students, option A is the right answer, that is smaller size. Moving to the next question. Question number 2nd. Gallium was named by Mendeleev as options. Option A, Aka aluminium. Option B, Aka silicon. Option C, Aka germanium. Option D, Aka zinc. Students, Mendeleev predicted the properties of some of the elements during his classification which were not yet discovered. And he named one of the element as Aka aluminium, which was later discovered as gallium. On the right side, you can see the part of periodic table in which right below the aluminium we are having gallium. Both these elements belong to group number 13 of p block elements. So below aluminium we find gallium, which was earlier called as Aka aluminium. So students, with this, the right answer is option A, Aka aluminium. Moving to the next question. The cause of periodic properties is, and the options are option A, increasing atomic radius. Option B, increasing atomic weight. Option C, number of electrons in the valence orbit. And option D, the reoccurrence of similar outer electronic configuration. So students, the reoccurrence of similar outer electronic configuration after certain regular intervals called as magic numbers. So the numbers are 2, 8, 8, 18, 18, 32. So these are called as magic numbers. So with this, the right answer is option D, the reoccurrence of similar outer electronic configurations. It is the main cause for the periodic properties in the table. Question 4. The percentage ionic character in a bond formed between chlorine and hydrogen is. Electronegativity of chlorine is 3.0 and hydrogen is 2.1, and the options are option A 17.2 9.235, option B 9.915, option C 10.2, and option D 6.182. Students, we are knowing that percentage ionic character, which is equal to 16 into difference of electronegativity value between the first element and the second element. So let us consider the first element to be chlorine and second element to be hydrogen. So XA minus XB plus 3.5 into the difference of electronegativity, the square. So with this, substituting the values, we get percentage ionic character is equal to 16 into XA means electronegativity of chlorine. So we can write 3.0 minus XB means electronegativity of hydrogen, which is 2.1, plus 3.5 into 3.0 electronegativity of chlorine minus 2.1 electronegativity of hydrogen, the square. So if we solve this, we get 16 into 0.9 plus 3.5 into 0.81. And finally, we get the answer as 17.235. With this, students, option A is the right answer to be percentage ionic character when a bond is formed between chlorine and the hydrogen. Moving to the next question. The electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6 and 3d9 represents a, options are option A, metal atom, option B, non-metal atom, option C, non-metallic anion, and option D, metallic cation. Students, the given configuration represents the configuration of a cupric cation because the atomic number of copper is 29 and the electronic configuration which has been represented here is having 27 electrons, that is 1s2, 2s2, 2p6, the first 10 electrons, 3s2, 3p6, next 8 electrons, so in total 18 electrons, 3d9, so it is 27 electrons. Copper has 29 electrons, 2 electrons are lost to form cupric cation, and which is a metallic cation. So with this, the right answer is option D, metallic cation. Question number 6. Elements whose outer electronic configuration may vary from ns2 np1 to ns2 np6 constitute. Option A, S block elements, option B, P block elements, option C, D block elements, and option D, F block elements. Students, P block elements consist of elements belonging to the group 13 up to group number 18, that is noble gas family. So the outer electronic configuration is ns2 np1 to 6, and at the end of each period there is a noble gas element. Outermost electronic configuration of the noble gas is ns2 np6. For example, in case of neon, the configuration is 1s2, 2s2, 2p6. So students, we are having outer electronic configuration in case of neon as 2s2, 2p6, which obeys ns2, np6. So with this, the right answer is option B, P block elements. Moving to the next question. Which one of the following is not a characteristic of p block elements? Options are: option A, the last electron enters into p orbital. Option B, they mostly form covalent compounds. Option C, in any row, the metallic character decreases from left to right. And option D, the oxidizing power decreases from left to right. Students, as the electronegativity and electron gain enthalpy or electron gain energy of the elements increases across the period, that is from left side to right side in any given period, therefore their oxidizing power also increases from left to right. So students, option D is the right answer, that is the oxidizing power decreases from left to right is not a characteristic of p block elements. Question number 8. Which of the following has highest radius? And the options are: option A, 1s2, 2s2, 2p6, 3s2. Option B, 1s2, 2s2, 2p6, 3s2, 3p1. Option C, 1s2, 2s2, 2p6, 3s2, 3p3. And option D, 1s2, 2s2, 2p6, 3s2, 3p5. So students, they are asking you about which of the following has largest radius. In this case, as the nuclear charge increases, the atomic size decreases, because students, option A, if we see, it is having in total 10 plus 2, that is 12 electrons, whereas option B is having 13 electrons, option C is having 15 electrons, option D is having 17 electrons. So students, we are moving across the period with the given options. So across the period, atomic size decreases because addition of electrons occurs in the same shell. So students, as the nuclear charge increases, the atomic size decreases. So with this, the right answer is option A, 1s2, 2s2, 2p6, 3s2, and this electronic configuration corresponds magnesium metal. Moving to the next question. Which of the following isoelectronic ions has lowest ionization enthalpy? And the options are: option A, potassium cation, option B, calcium cation, option C, chloride anion, and option D, sulfide anion. Students, sulfide anion among all the four has the highest size and hence has the lowest ionization enthalpy value, because the given ions are isoelectronic ions, that is they are having same number of electrons but different number of protons. In case of sulfide anion, the number of electrons is 16 plus 2, that is 18 electrons, whereas number of protons is equal to 16. So with 16 protons, students, sulfide anion gets the largest size when compared to potassium cation, calcium cation, and chloride anion. When the size is largest for sulfide anion, removal of the electron becomes easier. Thus, it has got lowest ionization enthalpy value. So answer is option D, sulfide anion. Question number 10. The decreasing order of the second ionization enthalpy is, and the options are option A, potassium, calcium, barium, decreasing order. Option B, calcium, barium, potassium. Option C, barium, potassium and calcium. Option D, potassium, barium, calcium in decreasing order. Students, second ionization enthalpy of potassium is much higher than those of calcium and barium, because in case of potassium, the second electron has to be removed from the noble gas, that is argon core, while this is not so in the case of calcium and barium, because students, it is known to you that potassium atomic number 19, so 18 electron we can account for argon, the noble gas, and 1 electron which can be very easily removed for the formation of K plus ion. But if we want to remove one more electron from that 18 electron, the energy required would be very high. In case of calcium, students, atomic number is 20. So we can very easily remove first and second electron so that we get argon configuration for calcium cation. Similarly, in case of barium, out of calcium and barium, students, if we compare, the second ionization energy of calcium is higher compared to that of barium, and because of the smaller size of its. Thus, the overall sequence in the decreasing order is potassium, calcium and barium. So students, option A is the right answer. Question number 11. In which of the following species the size of the first species is not more than that of second? And the options are option A, lithium and fluorine. Option B, ferrous and ferric. Option C, sodium cation and fluoride anion. Option D, sulfur and oxygen. Students, sodium cation and fluoride anion are isoelectronic ions, because in case of sodium cation, sodium atomic number is 11. So removal of one electron from sodium results in total number of electrons in sodium cation as 10. Whereas in case of fluoride anion, atomic number of fluorine is 9. To form fluoride, gaining of one electron occurs. So we get total number of electrons as 9 plus 1 equal to 10. So sodium cation and fluoride anion are isoelectronic ions. Since amongst isoelectronic ions, the size of the anion is larger than that of the cation. Therefore, sodium cation has got smaller size compared to that of fluoride anion. So with this, the right answer is option C, sodium cation and fluoride anion. Question 12. The element having very high ionization enthalpy but positive electron gain enthalpy is options. Option A, hydrogen. Option B, fluorine. Option C, helium. And option D, beryllium. Students, helium has got highest ionization enthalpy because of its small size and stable inert gas configuration. The configuration of helium is 1s2 because atomic number of helium is 2. Helium has positive electron affinity because of its subshell, that is 1s2, which is completely filled. With this, the answer is option C, helium. Moving to the next question. The heaviest element among the following is option A, uranium, option B, radium, option C, lead, and option D, mercury. Students, among uranium, radium, lead, and mercury, the radioactive element, that is uranium, is the heaviest among all. So the right answer is option A, uranium. Question 14. The IUPAC name of 112 element is options. Students, in question they are asking you about 112 element. So first digit is 1. So we represent it as UN, un, and the second digit is again 1. So we need to represent once again un, followed by the third digit is 2. So the letter has to be bi, by, for the number 2, and the suffix has to be em, ium. So in total the name is unbium. So the right answer is option B, unbium. Question 15. Which of the following sets contains a pair of elements that do not belong to the same group but show chemical resemblance? And the options are option A, boron, aluminium, option B, beryllium and aluminium, option C, zirconium and HF, option D, potassium and rubidium. Students, in the question they are asking you about the set which contains a pair of elements that do not belong to the same group but show chemical resemblance. So it is diagonal relationship, which are not belonging to the same group but they exhibit certain chemical resemblance. That is diagonal relationship. So students, beryllium and aluminium exhibits the diagonal relationship. So the answer is option B, beryllium and aluminium. Question 16. Which of the following elements is a metalloid? And options are option A, lead, option B, tin, option C, antimony, and option D, molybdenum. Students, in the question they are asking you about which is the element which is a metalloid. We need to understand meaning of metalloid first. The elements which possess the characteristics of both metals as well as that of non-metals, they are called as metalloids. Among the four, antimony is a metalloid which is having both metallic as well as non-metallic characteristics. So the option C is the right answer. Moving to the next question. Variable oxidation state and degenerate orbitals shows option A, S block elements, option B, P block elements, option C, D block elements, and option D, all of this. Students, D block elements have variable oxidation states and even degenerate orbitals. So with this, option C is the right answer, that is D block elements. Question number 18. Which of the following have no unit? Option A, electronegativity, option B, electron gain enthalpy, option C, ionization enthalpy, and option D, atomic radius. Students, electronegativity doesn't have any unit, whereas electron gain enthalpy and ionization enthalpy has the unit of kilojoules per mole, whereas atomic radius is measured in terms of picometer, but electronegativity doesn't have any unit. So the right answer is option A, electronegativity. Question 19. Which one of the following has the largest size? And the options are option A, sodium anion, option B, sodium atom, option C, sodium cation, and option D, beryllium. Students, always when negative charge increases, size increases. If we compare between neutral atom and anion, so anions are having relatively larger size compared to its neutral parent atom. So the right answer is option A, sodium anion. Question 20. The diagonal partner of the element boron is, and the options are option A, lithium, option B, aluminium, option C, silicon, and option D, magnesium. Students, we need to understand diagonal partner means the diagonal relationship. The similarities in properties of the elements which are placed in different groups are called as diagonal relationship. In this case, the element boron is diagonally similar to silicon. So the option C is the right answer. Question 21st. Representative elements belong to option A, S and P block elements, option B, D block elements only, option C, F block elements, that is lanthanide and actinide series, option D, both D and F block elements. Students, the elements of group first and group second. Group first, alkali metals, and group second, alkaline earth metals, along with the elements of group 13 to group 18 are known as representative elements. And students, you are knowing that group first to group second elements are called as S block elements, whereas group number 13 to group number 18 elements are referred as P block elements. With this, the right answer is option A, S and P block elements. Moving to the next question. The ionization of hydrogen atom would give rise to, options are option A, hydride ion, option B, hydronium ion, option C, proton, and option D, hydroxyl ion. Students, the right answer is option C, proton, because hydrogen gaseous atom in the presence of first ionization enthalpy or energy loses one of the electron to form H plus ion, that is hydrogen ion or the proton. 23rd question. The number of elements present in fifth period is option A, 18 elements, option B, 32 elements, option C, 8 elements, and option D, 24 elements in fifth period. Students, fifth period actually contains 18 elements. So option A is the right answer, that is 18 elements. Moving to the next question, 24. Among halogens, the correct order of amount of energy released in electron gain or electron gain enthalpy or electron affinity is options. Option A, fluorine, chlorine, bromine, iodine in the decreasing order. Option B, chlorine, fluorine, bromine, iodine in the increasing order. Option C, chlorine, fluorine, bromine, iodine in the decreasing order. And option D, fluorine, chlorine, bromine and iodine in the increasing order. Students, electron gain enthalpy becomes less negative on moving down a group due to increase in atomic size. However, the electron gain enthalpy of fluorine is less negative when compared with chlorine due to electron-electron repulsion in small-sized fluorine atom. Thus, fluorine, chlorine, bromine and iodine have delta H values in terms of kilojoule per mole, as fluorine with minus 328, chlorine minus 349, bromine minus 325 and iodine as minus 295. Thus, the correct order is chlorine with the value 349, the highest, fluorine with 328, third, bromine with 325 and least value for iodine as 295 in the decreasing order. So option C is the right answer. Question 25. Electronic configurations of 4 elements A, B, C and D are given below. A element with the configuration 1s2, 2s2, 2p6. Element B with the configuration 1s2, 2s2, 2p4. Element C with the configuration, students, 1s2, 2s2, 2p6, 3s1. And element D 1s2, 2s2, 2p5. Which of the following is the correct order of increasing tendency to gain the electrons? And the options are option A, C, B, D, and option B, A, B, C, D, and option C, D, B, C, A, and option D, D, A, B, C. Students, let us first consider the element A with the configuration 1s2, 2s2, 2p6. So this corresponds to atomic number 10 because we are having 10 electrons. So this is neon element, noble gas. Element B with the configuration 1s2, 2s2, 2p4. So in total we are having 8 electrons. Atomic number 8, which corresponds to oxygen element. Element C with the configuration 1s2, 2s2, 2p6, 3s1. So in total we are having 10 plus 1, that is atomic number 11. 11 electrons, thus atomic number equal to 11 with the element sodium. And the next D element with the configuration 1s2, 2s2, 2p5. In total the number of electrons are 9. So atomic number 9 corresponds to fluorine. So students, the electron gain enthalpy or electron affinity value increases along a period, that is from left side to right side, and also it decreases down the group. Element A is a noble gas, that is neon, with the low electron affinity, whereas element C, students, which is a sodium metal, which rather tends to lose the electron. Thus, electron affinity with element C is less. In case of element B, which is oxygen, it has higher amount of electron affinity, whereas in element D, that is fluorine, it has the highest among all the 4 electron affinity value and because of its small size. Thus, the correct order of electron affinity is element A, C, B, D in the increasing order. So option A is the right answer. Thank you, students.